Hello. So this is chapter 9 slides from GLS. Not all of the ideas in GLS will be here. Please read the rest of the chapter or the entirety of the chapter. The idea here is to, as we go through these slides, it'll give you some big ideas so that when you read the GLS pages, chapter 9 pages, you'll be able to appreciate it more and you'll be ready to solve some end of chapter problems, problem sets. Now, we ended with the intertemporal budget constraint here. I won't belabor this point, except that the left-hand side is the present value of consumption, and the right-hand side is the present value of income, exogenous income. The new element for the rest of chapter 9 is the objective function here, which are contained, which have as its parts the individual utility function for each time period, the present and the future. Now, the utility function here will have a specific functional form if you're solving something explicitly. And there are examples of that in the book. And those are the examples we'll be using as well in end of chapter problems and in exams. It has certain properties. The marginal utility is positive. It has diminishing returns, diminishing marginal utility, I should say. Basically, as you consume more, marginal utility falls. And maybe this is something you haven't seen yet. As consumption goes to zero, your marginal utility goes to infinity. This assures you that you don't have a zero solution, because the moment you're close to zero, the reward for consuming a little bit goes through the roof. Next is, so notice that the objective function here is the sum of present and future margin utility. To add those two numbers together, you need to turn the future utility into its present value, which is the point of beta. Now, beta is less than 1, and you consider that, or you'll call that utility discount factor. And if you multiply utility by beta, it will turn it into its present value, right? So that's why now you can add the present value of present consumption as well as the present value of future utility. Now rewrite the constraint from the intertemporal budget constraint here as follows. So notice that your consumption in the future is going to be equal to the income in the future plus whatever savings you're able to accrue, or minus, if this is a negative number, some debt that you need to pay off. Now insert this into the objective function here. And note that now your entire objective function is a function of CT. CT there and CT here. So now you only have one variable that you need to vary, CT. Now that makes sense because, like we said, the intertemporal budget line tells you that your CT decision is basically an S or savings decision, which will impact your future consumption. So the future and the present are linked. So if you get the first derivative of this with respect to C, you'll get the following equation. So this is just the derivative of the first term here. And then the derivative of the second term is using the chain rule. You will get the derivative of the outer function, bu prime. Then you get the derivative of the inner function here, which is negative 1 plus r here. So you have a negative and then 1 plus r, and then you equate that to 0. So copying the equation again here, you replace the thing inside with CT plus 1, and you move everything to the right-hand side. So the 0 is gone. So now you have a marginal benefit, marginal cost interpretation to the first order condition. And this is what's called the Euler equation. It'll give you the time path or the law of motion for consumption, generally speaking. So one of the most important concepts in this book is the Euler equation. So you should take time to understand the intuition of the Euler equation. So as for the intuition, it's just the MRT is equal to MRS of the model, right? This is the efficiency condition. Now start with the left-hand side. An increase in CT by 1 unit, then you get a marginal utility of this, marginal utility of CT. So that's good. You get a benefit by consuming more, right? Now, what's the cost of this? So if you're in your intertemporal budget line, to get more CT or a positive CT, your CT plus 1 consumption has to fall, right? In particular, it will fall, your CT plus 1 will fall by RT, 1 plus RT plus 1. Or in equation form, your change in CT plus 1 is going to be equal to negative 1 plus RT times delta CT. Okay. So this comes directly from the intertemporal budget constraint. As you are choosing to consume more, you will, because of the budget constraint, consume less tomorrow. Now, by consuming less tomorrow, that means you will have a higher marginal utility in the future, right? Because of the diminishing marginal utility idea. That means if you consume less tomorrow, the benefit or the reward for consuming more tomorrow goes up. So you'll want to basically try to consume more tomorrow, right? So this is the foregone utility. By lowering your consumption by that much, you are missing out on a higher marginal utility. So that's why the right-hand side here is called the cost or the marginal cost of consuming more in the present. Finally, to be able to compare the left-hand side, which is the present marginal utility, to the future marginal utility here, you have to multiply it with beta to turn it into its present value. This term here is the same as this equation here is the same as the Euler equation, except that now you have the delta CT that we had talked about. And here, this 1 plus RT times delta CT, this is delta CT plus 1. This is the increase, or I should say the decrease in future consumption, given the fact that you have an increase in future consumption here. Using the graph, this is just the MRT is equal to MRS. The Euler equation is basically MRT is equal to MRS. Okay. The red lines are the indifference curve and the slope of the indifference curve at that point. The slope of the indifference curve should be mu prime divided by beta mu prime CT plus 1, this one. Now, to get MRS equals to MRT, you have to equate the slope of the indifference curve to the slope of the intertemporal budget line, which is, if you recall, it's 1 plus R. So you do this equals 1 plus R. Super simple manipulations will get you to the Euler equation. So please confirm that. Now we go back to the intertemporal budget line. So notice that your axes are CT plus 1, and this is CT. This is your budget line. Your endowment is here. Remember that this is exogenous, YT and YT plus 1. If you choose to consume down here, that means your CT is greater than YT. That means you're borrowing. And if you consume up here, that means that this spot, your consumption is less than your income. That means you're saving. So this is the saving segment, and it's the borrowing segment. Now, changing slope means you're changing the slope of the intertemporal budget line. Note that in this particular case, you're just changing 1 plus R. You're not changing the endowment. So anytime you change 1 plus R, you're just pivoting the line around the endowment point here. So this steeper line is with a higher R, and this flatter line here is with a lower R. Also note that the intercepts here will also change, right? As you change 1 plus R. Yeah, the thing that doesn't change, of course, is the endowment, which is just here. Next concept, what happens if you increase your YT or your YT plus 1? In this example, in either case, whether you increase your YT or YT plus 1, it's going to be essentially a shift to the right of the budget line. Okay. In this particular example, this is your initial YT plus 1. Then you increased both of them, and that means you're shifting the line to the right. Notice that it's a shift of the line because the 1 plus R, the slope does not change. Also note that it doesn't really matter if you increase only one YT or only YT plus 1. So for instance, if you increase YT only and keep YT plus 1 constant, and that means the YT plus 1 here is the same, and then you're basically going to shift this gap here is the change in your YT, your present income. And you're still going to draw a new line hitting this dot. So it's the same idea as shifting the line out. Okay. So that's the first idea. An increase in YT or YT plus 1 will shift the intertemporal budget line up or to the right. But most importantly, not all of the increase in Y will lead to an increase in C, or the MPC will be less than 1. So that's an important idea that as long as you are free to choose along the intertemporal budget line, if you shift your intertemporal budget line to the right, your consumption bundle will not change entirely by the increase in income. Yeah. Okay. This last part here, so here I had thought that instead of moving both of them going up, you will increase your YT only. So if you increase your YT only, this blue dot will be here, right? You can move this blue dot down here. And then there'll be this change in YT here. And what the book is saying is that if your consumption changes by this much, if your consumption changes by this much, then that means your MPC is equal to 1. Okay. There are situations when that will happen, but normally that's not going to happen. Okay. Normally your MPC will be less than 1. All right, next. So this is something you probably encountered in your other classes, so we won't belabor this too much. Again, this is the endowment. This is the original consumption point. And let's say that your budget line becomes steeper and R rises. So this orange area used to be possible, but now it's no longer possible for you as a borrower. Now, your new consumption choice will be along this new feasible budget line here, down here, in this area here. Notice that this green area represents a lower CT. So when you're a borrower and R goes up, for sure, your CT will go down, right? From red to whatever point along this green line. Any point here is theoretically possible. It depends on the utility function itself. But either way, whatever happens, your CT will go down. Okay? Your income and substitution effects go in the same direction. But now, initially, you're a saver. So if you're initially a saver, you're down here in this flatter line. R goes up, becomes steeper, pivoting around the endowment here. Now, this dark green segment, this is when the substitution effect exceeds the income effect. And in that case, your CT will fall, right? In this area here. Because this is your current CT, you're going to lower your CT in the face of an increase in R. But if your income effect is large enough, it's possible for you to be in this light green area here, or in this light green area, you'll see an increase in CT. Okay, so in this area here. So normally we will assume that the substitution effect is stronger than income effect, and you'll be here. So notice the substitution and income effect stuff only affects CT. It's only really, we're only really talking about what happens to current consumption. Future consumption will tend to rise because when R rises, that has a direct effect of simply increasing your future income because you'll tend to consume more because of that effect there when your income goes up. Now, precautionary saving is an important part of the chapter. It's another reason to save. So, given uncertainty in future Y and future consumption, there's another reason to save called precautionary saving. Now, in the event that there is uncertainty in consumption, your Euler equation becomes this one. So notice that you're applying an expectation operator onto the marginal utility of future consumption because your marginal utility of future consumption is unknown at present because there's uncertainty, right? Notice that your RT is known or exogenous. So this has nothing, this is no uncertainty related to it. So that's why it's outside of the expectations operator. So here, expectations is just EE. The E is just the expectations operator. This is just the expected value or the average given, the unknown or random variable, like the average of the random variable. Here we use it to get the expected value of marginal utility because this term here goes directly into the Euler equation. Now, notice the shape of the marginal utility function. In general, because of this shape, It's got a convex shape. In general, we'll find that the expected marginal utility will be greater than the utility of expected consumption or average consumption. So this relationship here, this inequality, is called Jensen's inequality, generally speaking. And it has applications in statistics, not just in math or economics. And here you'll see Jensen's inequality directly. So notice that there's uncertainty in consumption. Consumption could be high, consumption can be low, and here's the average consumption. But what you want to know is your expected marginal utility. So when consumption is low, your marginal utility is high. When consumption is high, your marginal utility is low. Then you get the average of your marginal utilities, which is this thing here. And notice that the average marginal utility is greater than the value of marginal utility at the average consumption level. So that's this. So see this gap, vertical gap here. This is the gap represented by this inequality from the Jensen's inequality. Now, when we have an increase in uncertainty, where the expected consumption is preserved, you'll find that expected marginal utility will rise. So the right-hand side of the Euler equation will tend to go up. Where we had talked about what the interpretation of this is the reward to saving, the reward to future consumption. So that goes up, which will tend to make you want to consume more in the future to save more in the present. Okay. So let's check it out. So here below, you have a mean preserving increase in uncertainty in consumption. So before it's C0H, C0L, the average is expected CT. But now now your high consumption is higher and your low consumption is lower, but because the high went up by the same amount that low went down, your average still the same. The point here is what will happen to your expected marginal utility. So notice that this is the old expected marginal utility. Your new expected marginal utility is higher here. So an increase in uncertainty will increase this term here, which will tend to make you want to save more or consume more in the future. The next concept is the borrowing constraint. So in a borrowing constraint, this tells you that if you are at your endowment here, so notice your consumption is equal to your endowment, you may not actually be in this borrowing area here, right? And this is an extreme borrowing constraint. That means no borrowing at all can happen here. Notice that if borrowing were allowed, then you would choose to be a borrower. So you would choose to consume here and borrow in the first period, borrow in the present. Okay. So what's the big idea? If you are constrained, oh, by the way, I should before going. If this is the equilibrium when you're unconstrained. When you are constrained, you are going to look at this corner here. So if you recall our discussion on linear programming, when you have these kinds of constraints where you have these sharp corners, you should one of the easy ways to find the solution is to look at the value of the utility at those corners. In particular, you can use the graph, the indifference curve graph here, to show that you'll probably hit or be tangent to this corner here, where you are completely consuming in the present period all of your income. Okay, that's sort of the effect of having a binding borrowing constraint. You want to be down here, but you can't because you're stuck there. The best you can do is be out there, right? All right, so this is your original constraint, and the idea of this graph is what if your income goes up from y0 to y1? What happens then? From a graphical point of view, your borrowing constraint moves from this black sloping line here and vertical line here to this blue sloping line and this black vertical line, right? Okay, so notice that this dot here and then this dot here, these are corresponding to the old and the new equilibrium, but both of them are constrained. Both of them would like, at both of these situations, they would like to actually be a borrower, which is represented by the black dashed and the blue dashed lines here. Okay. Now, the main insight here, guys, is if you are constrained and I increase your income and you continue to be constrained, your entire income change here will go to your current consumption. No saving will actually happen. So your C will go from C0 to C1, which is exactly equal to the increase in income from Y0 to Y1. All right, so these are some of the big ideas of chapter 9. Please reread chapter 9 and let's try to do some problem solving on the next time we see each other. All right, bye-bye.